Hi students, today I have come with another new interesting problem which is given in Rahul Sardana in rotational dynamics. Right. So let us once see that problem. A solid hemisphere rests on a truck as shown in the figure. If the coefficient of friction mu is just sufficient to prevent slipping, calculate the acceleration of the truck. It's just asking us to calculate the acceleration of truck. How to calculate the acceleration of truck here? Based on that hemisphere, we are going to calculate the acceleration of truck. How? Let us draw the free body diagram of this solid hemisphere, okay? So let us draw it. Now this is a solid hemisphere, okay? And consider this is the center of the solid hemisphere, okay? And radius of the solid hemisphere is this one. This is a radius, okay? How it is kept on a floor? It is kept on the floor of the truck. It is kept on the floor of the truck. Quite interesting. Consider this is a point P, which is in contact with the floor. This is a point P of the hemi-solid sphere, which is in contact with floor. Now, if we want to draw the forces which are acting on it, first of all, let us draw the forces. First point, we need to draw weight, right? Where to draw the weight? At the center of mass. Where is the center of mass of it? We all know that for the solid sphere, the center of mass will be located at a distance of this is, consider this is first small r. Here is the center of mass. Here is the center of mass. Okay. So r will be what? What is the value of r here? As we all know that for a hemi-solid sphere, center of mass is at a distance of 3r by 8 from the point O. This is a point O. Yes or no? So this is 3r by 8. If it is a hemi-halo sphere, then it will be at r by 2. Like that, there are some objects for which we have to find the center of mass. Yes. Among that, we are taking the center of mass position of hemi-solid sphere. Okay, if it is at r distance, now what is the direction of force acting on it? The direction of weight acting on it is mg here. Okay. And is there any other force once observed here? Yes, definitely. Am I right? Definitely there is another force. That is the reason why the hemisphere is tilting to some extent. Am I right or not? It is tilting. Why is it tilting? Because it is kept on non-inertial frame of reference. This is a truck and its acceleration, let us assume it is A. So that we can say that the hemi-solid sphere is a little bit tilted because of some other force. What is that other force? That is pseudo force, right? So that pseudo force will act in this direction. That pseudo force will act in this direction. Yes. Consider and how to find that value of pseudo force? Nothing but pseudo force value. Pseudo force is equal to mass of the object into acceleration of reference frame. And the direction of pseudo force is opposite to the direction of acceleration of reference frame. Yes, sir. Reference frame is truck reference frame. Truck is going towards right side. That's why pseudo force acts in the leftward direction. Okay. Okay, right. Now there are two forces, mg and ma. There is one more force, that is n, and there is one more force also. There are two more forces here actually. Now let me draw those two forces also so that you'll have an idea. This is normal force, am I right? And there will be one more force, frictional force also. But I'm not going to take those two, normal as well as frictional force, into consideration, because the answer is not given in terms of mu. Okay, it is just enough. There is some enough friction to prevent it from sliding. That is a matter it has given here, right? So what am I going to do? I'm not taking normal force and frictional force here. Okay, enough friction is given. That's it. So we need not to discuss about that friction. Even answer is also not in terms of mu. Okay. Now let us take the two forces mg and mg and ma. Now the torque acting because of these two forces is equal to zero. Net torque acting because of mg as well as ma is equal to zero. That's the reason why it is at rest only. It is at rest with respect to truck. Am I right or not? So net torque is zero. It means the torque produced in clockwise direction. Okay. The moment in clockwise direction is equal to the moment in anti-clockwise direction, right? So like that, if we take the torque due to mg, that is weight. How to write the torque due to weight? That is tau w is equal to mg into, what is its perpendicular distance? How to draw the perpendicular distance? Now we are going to write with respect to P here. Important to understand, with respect to P. Torque due to weight with respect to what? With respect to point P. So now you can write from the point P, what is the perpendicular distance? This is a perpendicular distance. Observe carefully. This is a perpendicular distance. Yes or no? With respect to point P. This is a perpendicular distance. Yes. So what? How much is that perpendicular distance? Here, if it is angle theta, if this angle is theta, observe, this angle is also theta. Yes or no? This angle is also theta, right? So therefore, now this value can be taken as r sine theta. R sine theta. So what is the perpendicular distance that we are going to write here? That is r sine theta. What is r here? We all know that r is equal to, it is 3. I'm sorry, here I have written small r, 3 capital R by 8, where capital R is the radius of that hemisphere, right? So now instead of small r, let me write 3 by 8 r sine theta. Okay, that is, let us write it clearly. 3 by 8 mg, sorry, mg r sine theta. And now that is about torque due to weight. Now let us write torque due to pseudo force. Torque due to pseudo force. Okay. Torque due to pseudo force is what? Tau F is equal to, consider it as tau F. We can write MA into, now it is important to write the perpendicular distance here. It is, we need to take care, because from point P we need to take the perpendicular distance. From point P, let me draw it clearly. This is a perpendicular distance from point P. Am I right or not? Line of force is MA in this direction towards left, and from point P, what is the perpendicular distance? That's one. So how to find that value? Can I write it as MA into, I'm going to write the perpendicular distance as, see this clearly, capital R minus R cos theta. Can I write like this? Because total radius, total from O to P distance is capital R. And in that, if I am subtracting R cos theta, so that I'm going to get the perpendicular distance from P to this point. Okay. Now, these two are equal. These two are equal. That's why it is not rotating at all, right? Therefore, torque due to weight is equal to torque due to F because of principle of moments, right? Let me write it here. So I'm going to write 3 by 8 mgr sine theta is equal to ma into r minus, instead of smaller, I can write 3 by 8 capital R into cos theta. So m gets cancelled here. Therefore, 3 by 8, here even we can cancel this r also. So 3 by 8 g sine theta is equal to a into 8 minus 3 cos theta divided by 8. So 8 gets cancelled. Therefore, I'm going to write the a value as acceleration. Acceleration we have got now. Acceleration is now 3g sine theta divided by 8 minus 3 cos theta. This is the answer given in that. So what is the answer? A is equal to 3g sine theta divided by 8 minus 3 cos theta. This is a very interesting problem, right? Now, here we need to understand where mg is acting. We'll directly take actually. Okay. But in order to find that where mg is acting, that is important. We need to know about center of mass, right? So that's it. This is about an interesting question which is given in Rahul Sardana. Keep watching my channel and please do like, share and subscribe to my channel, Physics Star. Thank you.